Welcome to our presentation on smart contracts and its potential application to Tesla's supply chain. We want to thank Sash, VP of Global Supply Chain Management, and Zachary Kirkhorn, CFO, in giving us the opportunity to assess the feasibility of this novel technology in addressing Tesla's supply chain issues. As you already know, we are the Sash Digital Consultancy. We were established in 1990 and have 30 years of experience in providing cutting-edge technology-driven solutions. We focus on getting past the hype of emerging technologies, building feasible solutions that provide strategic value to our clients.
As you have presented to us, Tesla has faced two key issues with the Model 3: large amounts of unsold inventory and long delivery times for customer orders, up to 10 weeks. These are inefficiencies you would understandably like to avoid for the upcoming launch of the Model Y. Our researchers have conducted financial analysis on the inventory turnover ratio, which indicates the number of times per year that average inventory is sold. We found that Tesla's inventory turnover ratio is substantially lower than competitors such as Toyota, an industry leader in efficiency. Before we delve deeper into our analysis, it'll be helpful to take a short step-by-step view of how Tesla's supply chain inefficiencies arise. Beginning from the top, the high degree of customizability of Tesla cars leads to a complex procurement process, as batteries and custom components need to be sourced rapidly from various suppliers according to demand. This has led to longer production times than the industry average, which, as you know, prompted Tesla to engage in batch production in an attempt to speed up the production process. Finally, this results in excess and thus inefficient inventory, as the vehicles are produced in bulk rather than made to order. As seen on the previous slide, our researchers have identified the overarching cause of Tesla's inefficiencies to be the high customizability of its cars and the resulting complexity of its supply chain. We appreciate that this customizability is a core element of Tesla's offerings, and will therefore not advise you to alter this in any way. However, it is important to address the key problems that result from this complexity. The first one, batch production, is something Tesla has been undertaking in an attempt to predict the commonly chosen customization options and have those vehicles ready to be sold. However, unlike many other firms in the auto industry, Tesla's vertically integrated supply chain makes batch production an unattractive option. Without a partnership with external dealerships, there is no financial or physical buffer for unsold vehicles. In other words, excess inventory has nowhere to go. This, naturally, leads to several inefficiencies, including a substandard inventory turnover ratio. The second key problem is weak supplier relationships. Our analysts discovered a history of Tesla suppliers reporting delayed or missing payments and requests for rebates in some cases. This has resulted in a lack of trust and confidence in working with Tesla for numerous suppliers. We understand that Tesla is at a point where ensuring profitability is necessary, and that the relative newness of the supply chain inherently translates to lower trust between all parties. However, weak supplier relationships will inevitably lead to a variety of problems, including difficulties in negotiations and potentially a refusal to work with Tesla in the future. Our analysts will now walk you through the solution that Sash recommends for you.
We have devised a solution based on smart contracts that will tackle both of these root problems, therefore alleviating the supply chain inefficiencies that Tesla faces. Smart contracts that operate on a distributed ledger will increase automation and transparency throughout your supply chain. The automation of transactions with your suppliers will help you transition to a just-in-time production model, which will eliminate the current low turnover and excess inventory issues. It also benefits your effort to regain trust from your suppliers because of the increased reliability of automated processes. Additionally, the transparency is achieved by creating a base of common knowledge with your suppliers, making information available across the whole supply chain in real time. This will increase flexibility, scalability, and robustness of the network. Now, what exactly does this solution entail? Here we have a short description of the idea behind smart contracts. We will not dive into too much detail regarding blockchains and distributed ledgers, as we have discussed that part of the solution last time already. A smart contract is essentially a digitized version of a traditional contract. They are, in theory, independent from distributed ledger technology, but distributed ledgers are the first to provide sufficient security for digitized contracts. First of all, the rights and obligations of the contract must be defined and coded. This digitized contract can then be uploaded onto the distributed ledger and the other participants then take it up and agree to fulfill it, which is known as the process of invitation. Alternatively, the smart contract can be agreed upon with all the parties before uploading it to the blockchain, which makes a different operating mode of the system possible. Together with the contract itself, also the different ways of executing will have to be defined. To give you an example, you can have a rental agreement that specifies how much rent you have to pay per time period, but it may not specify the exact date that you are paying the rent on. Once all this has been agreed upon and the contract is active on the blockchain, a trigger initiates the execution. This could be a GPS signal or any other automatic or manual input to the system. After the trigger, the smart contract executes the defined obligation to fulfill the agreement of the contract. Now our technical specialist will walk you through how a smart contract implementation for Tesla could look like.
So here is how smart contracts could look like in any select part of the Tesla supply chain. As you can see, smart contracts allow seamless, frictionless flow of goods and transactions. So whenever Tesla needs a certain type of material or component, they simply deploy a smart contract onto the distributed ledger, which the suppliers can track in real time and immediately get to work on fulfilling. A potential use of this could be Tesla's battery supply chain. Say there is a spike in the demand for the long-range Model 3 and you need to procure more of the 75 kilowatt batteries. You simply deploy a smart contract on the shared ledger and the battery suppliers can take immediate note and start fulfilling the contract. With GPS trackers on the containers, for example, the supplier will be able to send the materials to the Tesla Gigafactory, where as soon as it arrives, the contract will execute and the necessary documents and funds are transferred automatically. This can heavily speed up the procurement process, which can be very valuable when dealing with customizable products that need many different materials depending on the particular order. Now, how to actually implement this. First, you will need to create a distributed ledger with the control mechanisms of your choosing and implement it in the selected supply chain. Second, you need to reach an agreement on the standards for the smart contracts, and the content needs to be codable and unambiguous. Third, you of course also need to develop the smart contracts and make sure that the relevant parties are trained for the procedure of releasing and fulfilling them.
Once you have successfully implemented a tailored solution to one part of the supply chain, it would make sense to consider the application of smart contracts across the entirety of the Tesla supply chain. This would allow just-in-time systems to be implemented across the entire product supply chain, allowing for accurate forecasting and increased information symmetry in supply and demand. Additionally, all vehicle components would be subject to a seamless ordering process that would allow you to eliminate prior batch production solutions which were inefficient. As you know, the U.S. National Highway Traffic Safety Administration, or NHTSA, is currently investigating Tesla for possible battery defects in Model S and Model X vehicles. They have determined that the batteries may be a fire hazard even in non-crash situations. We share your concern that some of the quality assurance practices in battery production may be flawed. Applying smart contracts to your battery supply chain may allow you to better assess production quality by increasing traceability and transparency. Through serial numbers, smart sensors, or RFIDs, it is possible to trace each step of the supply chain from raw material procurement to end-user delivery in one comprehensive solution. Tracking a product's chain of custody through blockchain technology makes it easier to identify where the issue is taking place along the supply chain and also allows for a swifter response. This same principle applies to the ethical sourcing of raw materials for EV batteries. As you know, Amnesty International has reported on human rights abuses related to the mining of cobalt and lithium. While you have taken some responsibility by releasing a conflict minerals report and conducting audits, a smart contract solution will be much more effective in managing product traceability. It would also be a great opportunity to boost Tesla's corporate social responsibility. There are certain challenges and limitations in the implementation of smart contracts. First, since smart contract and blockchain technology is still relatively new, being an early adopter poses some risks. While adopting cutting-edge technology early may lead you to having a competitive advantage, the know-how of its implementation is still emergent. This means that there may be potential challenges such as high pioneering costs to get this technology up and running, as well as hiring the developers who have the requisite knowledge. Another problem is the issue of legacy systems. When implementing blockchain technologies, it is important to consider its adaptation to existing databases and ERP systems. Transitioning to a blockchain network may be difficult because the technology is not designed as middleware that ties easily with existing legacy systems. Adjusting existing infrastructure in an effort to accommodate blockchain may be a timely and complex process. Next is the potential issue of double network effects. A blockchain-based network has no value without the enabling of digital infrastructures. However, the stakeholders might be reluctant to invest in the technology infrastructure due to security and return on investment concerns. This paradox, therefore, leads to a situation where the technology will not generate value without users' input, and without a network of participants, there will be no value created from the platform. Lastly, we must address governance challenges, which are a key concern given the decentralized structure of blockchain applications. It is crucial that all stakeholders are involved in a comprehensive decision-making process where multiple interests are balanced. In particular, decision rights and control mechanisms need to be clearly defined. Next, our industry research expert will share some current implementations of smart contract technology.
We chose 3 use cases to illustrate the beneficial applications of smart contracts and how these benefits can be applied to Tesla. The first use case is an initiative by Maersk and IBM. TradeLand solution provides information to authorized participants in the supply chain only when required. This enables them to comply with regulatory frameworks while cutting administrative costs, decreasing lead times, and reducing risk through improved monitoring. The paperless trade initiative used smart contracts to automate the documentation process of the shipping industry securely and thereby strengthen the trust among the stakeholders. The second use case is the Grade 2 Intelligent Equipment Inc., a tire mold manufacturer in China. The company faces challenges in fully meeting the demand of the market due to the short delivery time and the high product customizability. The Enterprise Knowledge Sharing System (EKS) use smart contracts to make effective use of the select manufacturing resources by assigning tasks to different partners based on their manufacturing capabilities and strength. The third use case is the collaboration between Daimler AG and Icertis. To address the increasing complexity of the global supply chain, Icertis has developed an initiative together with Mercedes-Benz Cars, a subsidiary of Daimler AG, to address the sustainability and the visibility challenges in supply chain management. This initiative will leverage smart contracts built on Icertis blockchain network to ensure global sourcing and contracting practices adhere to Mercedes-Benz strict requirement for working conditions, environmental protection, and compliances without compromising contract confidentiality. Using the 3 use cases, we have demonstrated that the smart contract and blockchain technology is widely applicable regardless of the size and the industry of the company, with broad applications in document automation, knowledge sharing, and contract enforcement. We would like to emphasize on the growing adoption of smart contracts in the automotive industries by players of different scale.
And we believe this provides a unique opportunity for Tesla, a company known for innovation, to once again be an early mover in a technology with enormous upside. Based on the analysis from our researchers, we believe smart contracts can provide the solution for Tesla's supply chain challenges. Our findings show that in Tesla's case, the potential benefits outweigh the associated risk. Our 3 main takeaways are: 1. Smart contracts can create information symmetry across the entire supply chain. 2. Smart contracts enable the development of reliable and flexible relationships with suppliers. And 3. It is important to be aware of early adopter risks, governance challenges, and other limitations because smart contracts and blockchain technologies are still evolving fields. Therefore, our recommendation is for Tesla to strongly consider the implementation of smart contracts to enable a frictionless launch for the upcoming Model Y. To mitigate risk, we suggest that you start with a small part of your supply chain, for example, the procurement of batteries. Thank you for your time. We look forward to working with you in the future to implement this solution.